Since the late 1950s, humans have been sending stuff into space. Some of those things came back to Earth, and some didn't. And it's the stuff that got left behind that concerns people like Hugh Lewis.
I'm an engineer. I come from the University of Southampton, and I've been looking at the space debris problem for over a decade.
And that space debris problem he's just mentioned, it's a big one. To give you an idea of the scale, there are close to 18,000 artificial objects that are currently being tracked orbiting our planet. Out of this, only around 1,400 are operational satellites. Estimates suggest that there are also a further 170 million objects that are too small to be tracked.
The thing about space debris, and we're talking about artificial space debris, is that humans have put it there. So it's everything that we would put onto a launch vehicle. Could include the satellites themselves. The stage of the rocket is often left behind on orbit. And then you start to see other bits and pieces, some lens covers from instruments that are looking down at the Earth or looking out into space.
Astronauts have lost everything from spatulas to fully equipped tool bags. This is NASA astronaut Sunny Williams losing her camera in 2007.
Sunny, your camera is behind you. I hope it's tethered because it looks like it's passing underneath the arm. It's not.
And the only real way of getting rid of this junk is with our atmosphere.
The lower we are in altitude, the greater the density of the atmosphere.
This creates drag, which slows the object down and allows it to fall to Earth, burning up in our atmosphere as it does.
As you move away in altitude, so you get higher, those objects, they're not going to experience the same amount of drag. So if you take a typical satellite at around that 700, 800 kilometres altitude, it's going to be up there for centuries.
The American Vanguard 1 satellite was launched back in 1958. It is currently the oldest piece of artificial space junk orbiting the planet, and is estimated to be stuck in orbit for another 250 years. And as more of this debris accumulates, there's a real risk of them colliding.
And each collision would generate fragments, which would then go on and potentially hit other things. So if you have enough big objects there, then the worry is that you end up with what's known as a collision cascade. One collision just feeds the next, and so on.
This doomsday scenario actually has a name. It's called the Kessler syndrome, and it was first outlined in the late 1970s by a NASA scientist called Don Kessler.
Don essentially calculated how many objects you would need in particular regions of space in order for that to take place. And the worrying fact is that we've actually exceeded that number of objects in some regions of space around the Earth.
Even the smallest objects pose a real risk. This is a small crack in the window of the International Space Station caused by a tiny paint fragment travelling at around 17,000 miles per hour. And even if you forget about space exploration, our day-to-day lives rely on satellites for things like communications, security and weather.
And we start to lose those. At first it would be, one every so often. Then it would start to grow, it'd propagate through, and we start to see, okay, so our weather satellite's no longer providing us with information. It's like stepping back in history to before the space age, because we fundamentally have these services embedded in pretty much everything we do on a day-to-day basis.
Okay, so what can we do? Removing all that debris in space is probably beyond our capabilities at the moment, so we need to be realistic in the types of objects that we can remove.
And you typically find those objects are going to be the big ones, because if they were to be hit, they generate lots of fragments. So you want to take those out of the environment.
And there are a couple of methods. You could use a giant robotic arm to grab the piece of junk. You could throw a net over it, or you could even use a laser to destabilize its orbit and push it down to Earth. But there's another problem, and it's a biggie.
There's an outer space treaty that the United Nations produced. And part of that treaty it says that we can't deploy weapons in space. Any mission that you could fly that would remove a bit of junk, you can also remove somebody's active satellite. So having a system that is able to remove debris but also could be considered a weapon is a bit of a problem.
The barriers to solving this problem aren't due to limitations in technology or engineering, but in the way that we as people organise ourselves.
You have to be a little bit more than an engineer. Helping people understand the problem fundamentally is what you've got to do first. Helping them to understand that it's going to affect them in some way unless we take action. And I think that's what we really ought to be doing, not just with the space debris problem, but with many others as well.